So today, Common Core, what we're really going to do is we're going to add or subtract rational expressions.
What's the date today?
It's the 26th.
We can't see what it's on.
Okay, add or subtract rational expressions. Okay, and it is 3, 26, 18. Okay, how's that? Add or subtract. So rational, the whole thing about rational is just a fancy word for fraction. We've talked about that before, but I'll put it up there again. So rational is a fancy math word for fraction, okay? Anything that is in fractional form or can be a fraction is a rational number or rational expression, okay? So slide up. Okay, number 1. Oh, sorry. There you go, Renee. Number 1's pretty easy, right? I mean, number 1 is just basic 6th grade math. They have a common denominator, 5, right? Write it down. And then add the numerators. I got 1/5 plus 3/5. 1 plus 3 is 4. Boom. So if they have a common denominator, the first thing I do is I just write it down. If it already has a common denominator, boom, I just write it down and then add the numerators, okay? 2. Now the problem is they don't have a common denominator, but what we can do is we can multiply to make a 12, right? We need a common denominator, so I'm going to multiply both top and bottom by 3 over 3. And the reason I want to multiply by 3 over 3 is 2 reasons, right? 1 is to make the 12. Why do I multiply both by 3 over 3? Listen, this is actually a really important piece. I am multiplying by the number 1, which does not change the value of the fraction, correct? Anything times 1 is still the same. That's why it always has to be something over itself, so I don't change the number. So what I have now is 7/12 minus 3/12, but it's the same exact value, right? If I multiply 3 over 3, it's still the same value. Now I have my common denominator, which is 12, and now I can just go 7 minus 3 is 4. Okay, again, we're in 6th grade math right now. Agreed? Just 6th grade math.
You want to simplify 4/12?
Yes.
1/3.
Reduce into 1/3. Thanks, Claire.
You're welcome. Oh my gosh. Mr. Dugans, did you hear that?
What?
I saw something that Claire didn't see. I was just going to leave it like that. So
All right.
you change it.
No, we should reduce it. Okay, number 3. So I'll put 3 over here. I'll run out of room. So if I went 5/12 plus 3/8, I'm going to need to multiply both fractions, right? Because I need to make them the same. Probably 24, right? Do we agree? 24 would be the best denominator. So I think 24 would be the best denominator. So we need to make a common denominator. Well, all right. So 12 goes into 24 2 times. Times the 5 makes a 10, right? Because I'm going to multiply this one by 2 over 2. Multiply this by 3 over 3, right? So I get the 24, and 3 times 3 is 9. Now I have a common denominator, so I'm just going to go straight to writing the answer as 19/24. Okay, now this is, again, just 6th grade math. We haven't done anything. And the only reason I like to do it is because the rules are going to be the same. As far as example 4, 5, 6, and 7, the rules are the same. When we add or subtract, we need a common denominator. When we multiply and divide, we don't. When we add or subtract, we need a common denominator. When we multiply and divide, we don't. Okay? All right, so let's take a look at example 4. Pretty easy. It already has a common denominator, right? The bottoms of these two fractions are already the same. I like that. So let's just write it down, x plus 3. I sure will. Thanks, Tammy. Just write it down. Now, don't write it twice because it's just like the 5's up here, right? You just write down the 5. You don't write down 10. That'd be silly, right? So the common denominator is x plus 3, so I write it down. Now, in the numerator, we're just going to add the numerator. 3x plus 2x is a 5x, and a negative 4 plus 5 is a 1. If I could factor and reduce, I would. If I could reduce, factor and reduce, I would, but I can't. 5x plus 1 can't be factored, won't reduce, so that's my answer. Okay. When you do your homework today, I didn't write this book. If I had written this book, I would have put more problems in that could be reduced. They put in problems that don't reduce very well, so you'll get big answers. Forgive them. That's the way it goes, right? All right, let's look at example 5. Okay, and example 5 might reduce. So first of all, before we do anything, they already have the common denominator, don't they? So I'm going to write it down. Right off the bat, I have a x squared minus 4x. Okay? For the numerator, got to be careful of my subtract. Okay, let me circle that. Let me highlight. I'm going to highlight my subtract. I got to be careful because I am going to subtract to negative 5 eventually, right? I am going to subtract to negative 5, right? That's going to be a plus 5. Everybody agree with that? So let's be smart. 2x minus 4x makes a negative 2x, right? I get a negative 2x. And a negative 1 minus a minus. So it's really negative 1 plus 5. Negative 1 plus 5, which makes a plus 4, okay? Now, can we do anything more with this? Well, it might reduce. So the only way I can know if it reduces, I'm going to put reduce question mark. I don't know. Let's try factoring. So if I factor out a negative 2 out of the numerator, I'd have an x minus 2, right? And if I factor out an x, I'd have an x times an x minus 4, and nothing reduces, so either answer is fine. I would have liked to have gone cancel, cancel. Darn it, nothing cancels. So you can either take the first answer or the second. Both work because nothing reduced, right? Would have been great if something would have canceled, but doggone it, this one didn't work, okay? But some of those are coming up soon. Thumbs up so far? Okay. Example 6. Okay, example 6 is different. Example 6 is because there is no common denominator. So here's what we're going to do right off the bat. Little hint. Factor the denominators. Okay, put a little star. Not the numerators. That's the top, right? Don't factor the numerators until you're done. Because you can't add things, like you want to add like terms, right? You eventually want to add like terms. You wouldn't be able to if you've got it factored. Okay, so keep them like all regular terms. Okay, so right off the bat, let's factor this. Let's factor the denominator. Have an x plus 2 and an x plus 1, right? Okay, now it's like Sesame Street. What does this fraction have that this doesn't? What does this fraction have that this doesn't? An x plus 2, right? So to make them the same, this needs an x plus 2. We also need to use the property of 1. So we got to multiply by x plus 2 over x plus 2, okay? So we're going to multiply top and bottom by x plus 2 over an x plus 2, okay? Now we will have a common denominator, right? So our common denominator is going to be, all right, let's check it out. It's going to be our x plus 2 over our x plus 1, right? So we've got that. And on the numerator, right, let's write down what we have on the numerator. Okay, I'm going to do this in 2 steps so you can see it. I will have an x minus 1 plus, I'm going to have to go this times this times this. Okay, I'm going to have to do that simplification. Plus an x squared plus a 2x, okay? So I got my common denominator. I knew that they both needed an x plus 2, x plus 1. So I gave this an x plus 2. Wrote down my common denominator. And then I simplified the numerator of this fraction. Okay, let's see what we got now. Let's tidy it up. So I'm going to have an x squared plus a 3x minus 1 over an x plus 2, x plus 1. Okay, how's that look? Now, darn it, the numerator won't factor. It won't. And that's kind of good news because we're done. We're done. If we could factor it, we'd factor it. If we could cancel, we'd cancel. Kind of makes it kind of, whatever, but we're done. Because we can't factor, we can't cancel, we're done. Okay, how am I doing? Thumbs up? So, example 7. Same thing, we need a common denominator. But the first thing I'll do is factor the bottom, factor the denominator, okay? So this becomes like an x plus 3, x minus 3, doesn't it? Right? X squared minus 9 is an x plus 3, x minus 3. Okay, so what does this fraction have that this doesn't? It needs an x minus 3, right? This has an x minus 3, x plus 3, but this one doesn't. This does not have an x plus minus 3, so let's give it an x minus 3. So I'll get an x minus 3 over an x minus 3. Squish that in there. Kind of squish, but that's okay, because I know I'm going to write down the common denominator, which is x plus 3, x minus 3. Okay. Now let's simplify the numerator. I'll get an x squared minus 3x, right? I'm going to get an x squared minus 3x, and then minus 18. This time I think we can factor and cancel. I like these problems because then if I can factor, cancel, I can get rid of some things. So I factor this, boom, boom, boom. I get an x minus 6, x plus 3, right? Over an x plus 3, x minus 3. And then this one's going to tidy up kind of nicely. I like this one because I can cancel my x plus 3 with my x plus 3, right? It's gone. What do we have left? X minus 6 over an x minus 3. I like that problem. It's always kind of fun when they cancel out and simplify. Makes it a little bit later. I know, you're looking at me like, Aim was like, okay, fun for you, Mr. Davies. I saw that look. Remember, I'm not a normal person, okay? Flip the page. Alright, number 8. Same kind of stuff. Let's go ahead and factor this into a x plus 2, x minus 2. You guys agree? Factor that into an x plus 2, x minus 2. So same thing. What does this one have that this doesn't? What does this first fraction have the second fraction needs? An x minus 2, right? Okay, let's see what happens. So I have my common denominator, which is my x plus 2. And then let's see what I'm going to have. Well, I might have to do a little work up here, but I'm not afraid of that. I'm doing a little work. Let's see what I'm going to have. I'm going to have a 2x squared minus 16. And let's see. Let's do a little work up above. Okay, let's do this. Let's take this. And let's do a little FOIL up above, because otherwise it gets pretty messy. But I'm going to do this up here. And what is a x plus 4 times x minus 2? So I can FOIL that, right? You guys agree? That becomes x squared minus 2x plus 4x minus 8, right? Just a little FOIL. So I'm just doing this work up here so I can bring it down. Otherwise I'm going to run out of room. So that really becomes an x squared plus a 2x minus 8, right? So I'm going to go minus this x squared plus 2x minus 8. Okay, so I did all that up there. Okay, Katie, question.
Would it just be easier to write negative x squared minus 2x plus 8?
Yes, you're ahead of me. Yes, yes, totally right. Okay, and I'm going to show that right now. Okay, so we're subtracting. So look at this. We're subtracting what we got here, right? And that's what I'm doing, subtracting what we got here. Katie's already changed the sign. She said, well, Mr. Davies, wouldn't it be easier to make that a negative x squared, negative 2x, and a positive 8? You guys agree with that? So let's do that next, okay? So then I'm going to have my x plus 2, my x minus 2, and I'm going to bring the negative through, right? So I'm bringing the negative through, push it through, push the negative through, so I'll have a 2x squared minus 16 minus x squared minus 2x plus 8, okay? How am I doing? I'm trying to show every step, and if you skip some steps, Katie, awesome to you, okay? I just like to show every step so nobody gets confused. Okay, let's tidy this up. So for the numerator, I'm going to have an x squared minus a x squared, 2x squared. 2x squared minus x squared makes a 1x squared, right? Minus 2x, because there's my minus 2x, and then minus 8. Okay, if I combine everything on top, 2x squared minus 1x squared is an x squared. Minus 2x, negative 16, and positive 8 makes a negative 8, okay? How am I doing? Over x plus 2, x minus 2, okay? Now, I can factor, can't I? Am I going too fast? Am I okay? I can factor. This will factor. This will factor into an x minus 4, x plus 2 over my x plus 2 and my x minus 2. And again, anything on the top after I've got it into a multiplication problem with anything on the bottom, so I can cancel the x plus 2 with the x plus 2, right? And what am I left with? Ta-da! Grand answer, x minus 4 over x minus 2. Do not cancel the x's. Do not make that a 2. They're different. Don't cancel and don't make that a 2. That is the answer. Do not cancel these because you have to subtract it before you can divide them. Order of operations, okay? All right, last problem. This is what we call a compound fraction. Compound fraction. It's a fraction within a fraction. Ugh. So, how do we do a compound fraction? Well, bit by bit. Okay, so what I'm going to do is, first, let's just take a look and try our best to be able to take care of these. Okay, so before I do anything, do a little side work. What is, I've got 2 over x plus x over 2, right? Okay, and I need to add these two. There's a plus sign, right? I need to add these two. They're two fractions, so I need a common denominator. So let's multiply this with 2 over 2 and the second fraction by x over x, right? Now all I'm doing, if I can cover this up, all I'm doing is trying to get a common denominator on top, okay? I'm going to let the bottom just come along for the ride for a while, and then I'm going to do something with it, okay? So on the top, right, numerator, I'm going to have a 4 plus x squared over a 2x, okay? 4 plus x squared over my 2x. Okay, here's my 4. Here's my 4 plus my x squared over my common denominator 2x. Now we got a fraction divided by a fraction. How do we divide fractions? Flip it, right? We flip it. So this is technically the second one. So we're going to flip this one and make it multiply, okay? Because you always flip the second one, or in this case, the bottom one. So we're going to rewrite this as a 4 plus x squared over 2x times flip x over x plus 1. And we can do one tiny little thing. I can cancel this x for this x. I'll have an answer finally of 4 plus x squared over 2 times x plus 1, okay? These aren't easy. You really should practice these. I mean, I can't physically make you do homework, but you know,